The most powerful space observatory ever built was damaged after a micrometeorite hit one of the 18 mirrors of the telescope, and the worst part is that this damage is irreversible. The universe is filled with so many mysteries, which is also the reason why we have the James Webb Telescope, to solve some of those mysteries, if not all. The James Webb Telescope was not always planned to be a huge project. It was originally estimated to cost about $4.96 billion and was supposed to launch in 2014. But several mismanagement and under-resourcing during critical early planning stages caused the ambitious spacecraft to fall way behind its schedule. That's when NASA restructured the project to launch it in 2018, and the total budget was increased to $8.8 billion. But the program struggled to address several technical problems which delayed the launch to 2021, which then added another $1 billion to the overall cost. But all of this investment will only make sense if James Webb Telescope is able to give us what we want, which is to show us what the universe is all about. Does this damage mean that NASA will fail to achieve their goals with this $9.8 billion telescope? Well, that's exactly what you will find out in this video. So make sure to stick around till the end of the video to know a lot more about the James Webb Space Telescope and whether this damage might affect future discoveries. Let's dive in. The James Webb Telescope is an infrared observatory that orbits the Sun about 1 million miles from Earth to learn about the very first galaxies that were formed in early universe, and also to observe the stars forming planetary systems. The James Webb Telescope was formerly known as the Next Generation Space Telescope, but it was then renamed in September 2002 after former NASA Administrator James Webb. If you think that NASA alone deserves credit for the James Webb Space Telescope, well, that is not the case because this is an international collaboration between NASA, the Canadian Space Agency, and the European Space Agency. This observatory is equipped with a large infrared telescope that has a 6.5-meter primary mirror. The James Webb Telescope is exciting because it will be studying the early phase in the history of our universe, all the way from the very first luminous glows after the Big Bang to the formation of solar systems that are capable of supporting life on planets similar to our own, to the evolution of our own solar system. You could say that the James Telescope is a spiritual successor to the Hubble Space Telescope, which means it will be building on Hubble Space Telescope's discoveries. The James Webb Telescope was launched on December 25, 2021 on Ariane 5 rocket from Europe's spaceport in French Guiana on the northeast coast of South America. On January 8, 2022, the James Webb team fully deployed the telescope's 21-foot gold-coated primary mirror, successfully completing the final stage of all major spacecraft deployments to prepare for scientific observations. This happens to be the first time a NASA-led mission has ever attempted to complete a complex sequence to unfold an observatory in space, which is an incredible achievement for NASA and the world. What makes things exciting would be the fact that Webb's current location will give us a wide view of the cosmos and will keep the telescope's optics and scientific instruments cold enough to function properly. But this location is also the reason why NASA calls the damage by the micrometeoroid impossible. The telescope was damaged earlier this year by at least 19 small space rocks called micrometeorites. Out of the 19 small rocks, one of them reportedly left a noticeable damage on one of the telescope's 18 gold-plated mirrors. This impact took place between May 23 and May 25, and it ended up causing irreversible damage in a small part of the space telescope. One of James Webb Space Telescope's primary goals was to look back through time to understand how galaxies were formed. And the telescope will be doing this by observing galaxies that are far away from us, and by far, we are talking about 13 billion light-years away from us. This is the reason why the James Webb Space Telescope is equipped with a large mirror. A telescope's sensitivity is directly related to the size of the mirror area that collects light from the objects being discovered. This simply means that if the area is large, it will be collecting more light, just like a larger bucket collecting more water than a small one. The James Webb Telescope team also decided to build mirrors in segments on a structure which folds up so that it could perfectly fit into a rocket. The mirror then unfolded right after the launch. The reason for the hexagonal shape is because it would allow for a roughly circular segmented mirror with high filling factor and 6-fold symmetry. Now, for those of you who don't know, a high filling factor means that the segments fit together without any gaps. If the segments were circular, there would be a lot of gaps between them. A roughly circular overall mirror shape makes sense because that focuses light into the most compact regions on the detector. An oval mirror, for example, would produce images that are elongated in one direction, and the square mirror would send a lot of light out of the central region. Now, micrometeorites have always been a problem for all kinds of spacecraft, even in the Earth's orbit, too. The U.S. Space Surveillance Network keeps track of over 23,000 pieces of debris that are large enough to cause damage to spacecraft. But these are just bigger pieces, and millions of smaller orbital debris pieces are almost impossible to monitor, which is a huge obstacle for any space exploration mission. But the existence of micrometeorites is not alien to the James Webb team, which is the reason why James Webb Telescope was actually built keeping micrometeorites in mind. Engineers would repeatedly intentionally hit the telescope with micrometeorite-sized objects to see if it would affect the working and performance of the telescope. This could also be the reason why most of the debris did not do huge damage to the James Webb Telescope's functioning. But one micrometeorite was large enough to cause damage. The entire team is now investigating the impact and trying to determine the intensity of the damage. NASA also added that it has not impaired the telescope's overall performance, which is a piece of positive news for some. Dr. Thomas Zurbuchen, Associate Administrator at NASA's Science Mission Directorate, foreshadowed the agency's ability to move beyond this setback when he tweeted in June about the early reports regarding micrometeoroid impacts on the telescope. Micrometeoroid strikes are an unavoidable aspect of operating in space, Zurbuchen wrote. Recently, Webb Telescope sustained an impact to one primary mirror segment. After initial assessments, the team found the telescope is still performing at a level that exceeds all mission requirements. The telescope is particularly vulnerable to meteor strikes because the mirrors are open and they are exposed to the vacuum of space. The Hubble Space Telescope, which happens to be the technological predecessor to the Webb, had a cylindrical housing inside which the observation technology was placed. The other reason why James Webb Space Telescope had to deal with a micrometeoroid strike has to do with the location of the James Webb Space Telescope. The Hubble Space Telescope was close enough for astronauts to operate from a space shuttle and perform all the required maintenance. But the James Webb Space Telescope, on the other hand, is far away in a stable point in space, where the Sun and Earth's gravity perfectly counterbalance each other in such a way that the telescope effectively stays still relative to Earth. The other problem with this particular position is the fact that very few spacecraft were sent to this point in space, known as Lagrange point or L2 point. This means astronomers don't have enough knowledge about the micrometeoroid risks in the region. But when you take a look at the low to medium Earth orbit, where the Hubble Space Telescope is situated, this is an area which is saturated with human spacecraft, so its risks were well studied previously. But does this mean that the telescope is a failure? Well, the James Webb Space Telescope is still performing beyond expectations, despite the damage by the micrometeorite. Yes, there are a few uncorrectable changes, but those changes are not causing any serious problems for the team. And the damage only affects one of the telescope's 18 gold-coated hexagonal mirrors. This means that the James Webb Space Telescope will still have another 17 mirrors to utilize without any damage. NASA is really confident about the telescope, as the team believes that it is still fully capable of achieving the discoveries it was built to achieve. The first full-color images have already revealed so much information for scientists, and the observatory will continue to search data on the early universe. The reason why the James Webb Space Telescope is exciting is because this telescope can look back billions of years through history to capture faint red-shifted light from the very beginning of the universe, which means it is here to rewrite cosmic history with a promise to revolutionize infrared astronomy. We might also be able to learn more about black holes while uncovering several mysteries of the universe that we are part of. And that is exactly what we want, because what we know about the universe is minuscule compared to what is out there. After all, this is the time machine that we never knew we wanted.